So the homework is to do 1 through 11 and 14 and 18. Let's jump to number 1. Let's just start from the beginning. Step 1 is to pick an equation and pick a letter to get by itself. So just think about this. If you wanted to get x by itself, it requires a lot of work. If you wanted to get y by itself, it requires a lot of work. Guess what? Up here, y is already by itself. So we're obviously going to pick that top equation. It already has the y solved for, so y is already by itself. So I could move on to step 2, which is to substitute this variable expression into the other equation I have not used. So I'm going to take the 6x and I'm going to plug it right into my y. Why am I plugging it into y? Because it says y equals, right? That's why I'm plugging it into y. If it would have said x equals, I'd plug it into x, but it says y. This equals y, so I plug it into y. And of course, I'm using arrows all over this place. My new equation becomes 2x plus 3 times y, but instead of y, I put parentheses, and I actually plug in the 6x, and then equals negative 20. And now I have an equation that I could actually solve. Let me just multiply, and then combine like terms, and then solve for x. So I'm going to multiply 3 times 6x, that's 18x. So I really have 2x plus 18x equals negative 20. And 2x plus 18x, I could combine like terms right there. That'll be 20 x's equaling negative 20. Final step would be to get rid of the 20 times in front of the x. So I divide by 20, cancels out, x equals negative 1. That's an answer. I have one answer, I need the other answer. Remember, an answer to a system is both the x and the y as a coordinate. So I so far have the x value, negative 1, and I need the y value, so all I need to do is plug it into any equation I want. Which one do you think is the easiest one to plug into? The top one. It has less numbers, it's smaller. I could take the negative 1 and simply plug it right in there into the x. It says x equals negative 1, that's why I'm plugging it into the x. So my top equation is really going to say y equals 6 times x, but we know x is really negative 1. So y really equals negative 6. So my final answer for number 1 is negative 1, comma negative 6. If you flip the paper over, you'll see that that's a correct ordered pair. That's the correct answer. If you're taking a quiz and you don't have the answers on the back, all you have to do is plug in your x into your x and plug in your y into your y. And you'll be able to verify that it works for both. Let's jump to other ones that are a little more fun, kind of like number 5. Which one's easier to solve for, x or y? Y. Definitely y, because it's already done, right? The top equation already has y by itself. So step 1 of picking an equation and solving for a letter, it's already done. All you have to do is take the variable expression and plug it into the equation you have not used. I'm going to plug it in to the bottom equation, and I'm plugging in for the y. Why? Because it says y equals. If it say x equals, then I'd plug it into x. But it says y equals this stuff, so I'm going to plug in this stuff in for y. Let me draw another arrow, rewrite my equation over here on the side. My new equation will be 2x minus y. Now, whenever you plug in, use parentheses. Equals 2. Notice that I put parentheses right there, and I'm actually going to substitute my 2x plus 6 right in there. 2x plus 6. Very important to use parentheses because most of the time you'll have something to distribute. Even if there's no number out here, it's kind of like if you had an invisible 1, or you could just say, I need to distribute that negative sign. Negative distributed to 2x becomes negative 2x. Negative distributed to positive 6 becomes negative 6. Bring down the rest. The 2x in the front, the equals the 2 over here. And now combine like terms and solve. However, when you combine like terms, when you say 2x, take away 2x, what happens? It cancels out, right? What do you have left? Negative 6 equals 2. Can negative 6 ever equal positive 2? Heck no. So that is impossible. So we say no, as in no solution. That's right. You could also do the symbol. What does that mean graphically? If I were to have graphed the system, they'd be parallel. That would not cross. If I asked you to classify it, you would say they're inconsistent. Let's take a look at the next one, number 6. Which one is the easiest letter to solve for? Y. It's already done for you. So obviously you're going to pick the bottom equation that already has y equals. That's the one you want to use. You're going to substitute the variable expression into the other equation that you have not used. And we're plugging it into the x or to the y? Into the y. Again, because it says y equals. If it said x equals, I'd plug it into the x. But it says y equals, I'm plugging it into the y. Let me make some space over here. So coming this way, I have a 3x plus y. But again, use parentheses when you plug it in. You end up with a negative x minus 2 right in there. And of course, it equals 12. Now, we use parentheses because most of the time we have something to distribute. However, this time, there's a plus sign. And that doesn't change anything, right? Most of the time, you have something to distribute. Right here, the plus sign does not change anything. So you don't even need the parentheses here. But it's good to use them because most of the time you will have something to distribute. So let me continue. My new equation is 3x plus negative x minus 2 equals 12. Does everybody understand that I had nothing to distribute? Okay. And now let's combine like terms. What's 3x plus negative x? That's 2x. And then bring down the rest. The minus 2 comes down, the equal sign comes down, and the 12 comes down. There's my new equation in red. Let me get x by itself by adding 2 right here, adding 2 over here. My new equation is 2x equals 14. So that's really 2 times x equals 14. Let's get rid of the multiplication of 2 by doing the opposite, dividing by 2. X equals 7. So we know that any system should have an answer that consists of a coordinate. I mean, unless it's no solution or infinitely many solutions. But right here we do have 7 as our x. We still need our y. So we could plug it into any equation we want at this point. So let's plug in the 7 into the top or the bottom. You pick. And it doesn't even matter. Bottom? Okay, so the bottom equation reads y equals negative x minus 2. I put it in parentheses because I'm going to substitute the value of 7 right in there. So that's really a negative 7 minus 2. So y equals negative 7 minus 2. That's just y equals negative 9. So your coordinate is 7 comma negative 9. This is your answer to the system. If you have some extra time, it's a good idea to always plug in your x, plug in your y into the x and into the y and see if it actually works. Or plug in your x, plug in your y into this x and this y and see if it actually gives you 12. But then again, we have our answers on the back of the worksheet, so you can just flip it over and check that way. Whoa, let's go to number 7. I'm going to try to get as many done in 15 minutes. Let's see where we're at from there. Number 7, what letter do you think would be the easiest to solve for? X, definitely. And on which one, the top or the bottom? The top. So this x is almost by itself. All I have to do is get rid of the plus 2y. So if I got rid of that plus 2y by subtracting 2y, and what you do to one side, you do to the other side, you're going to have a new equation. And that new equation reads x equals negative 2y plus 13. Are you with me? Okay. So that was step one, picking an equation and getting a letter by itself. Step two is to take the variable expression and plug it into the equation you have not used. Which one have we not used? The bottom. So let's plug it into the x or the y? To the x. Obviously, because it says x equals, that's why we're plugging it into x. Like I said, I draw arrows all over this thing. So over here, I'll have a negative 2 times x, but I want to put parentheses right there. And then minus 3y equals negative 18. And like I said, in those parentheses, I want to put the negative 2y plus 13 that the x equals above. Make sense? This binomial went right in there. There it is. The binomial's right in there with parentheses. Why is it important to use parentheses? Because most of the time, you have some distributive property to do, which we do right here. Check it out. Let me zoom in on this. Let's distribute the negative 2 on the outside. Negative 2 times negative 2y, positive 4y. Negative 2 times positive 13, negative 26. Bring down the minus 3y. Bring down the equal sign. Bring down the minus 18. There's your new equation. You still need to combine like terms. So let's combine the 4y with the negative 3y. What's 4y? Take away 3y. 1y. So we have 1y, or just y. Let me rewrite the rest. Minus 26 equals negative 18. What do I do next? Add 26. Cancels. Add 26. So you owe $18, but you have $26. Positive 8, that's right. So on the left side, it's just 1y. You could just write it as y equals positive 8. That's one answer. You need the other answer. What do we do? Plug it in. To which one? To any one you want. Sure, let's go with the top. The top one says x plus 2y equals 13. But the y we know is 8. So let's work out the math. That's really x plus 16 equals 13. So I need to subtract 16. And I end up with my final answer, x equals negative 3. So the answer to the system on number 7 is the coordinate negative 3, comma 8. And of course, if you have extra time, simply plug it in to verify, to double check that it works for both equations in your system. Looks like we have time for one more. Pick a letter to get by itself. X on the top one, right? So if you go for x on the top one, what do I have to do? Add 2y. You guys are on it. Plus 2y, plus 2y. So my new equation is going to be x equals 2y plus 3. Perfect, thank you. So then my second step is to take that value of 2y plus 3, plug it into the other equation we have not used into that letter, which is x. So I'm going to plug it in into the x. And now I'm going to rewrite everything, but instead of x, I'm going to put parentheses to plug that in. So we have 4x, 4 parentheses, minus 8y equals 12. And inside those parentheses, I'm going to plug in the 2y plus 3 that x equaled. And now let's focus in on this new single variable equation and let's solve it for it. Let's distribute 4 times 2y, that's 8y. 4 times 3, that's 12. Bring down the minus 8y. Bring down the equals. Bring down the 12. And now let's combine like terms. What's 8y take away 8y? 0. Cerote entero. And then I have 12 equals 12. What? Does 12 equal 12? Yes. When does 12 equal 12? Always. So right here, it's infinitely many solutions. Okay? Infinitely many solutions is the correct answer here. Now, what does that really mean? It means that if I were to have solved by graphing, if I would have gotten this in slope-intercept form and this one in slope-intercept form and graphed them, I would see that they're the same exact equation. They're the same exact line. They would land right on top of each other. So they have an infinite amount of points in common, right? So we say infinitely many solutions because there's really an infinite amount of answers that they have in common. Does that make sense? Now, if I would have ended up with something impossible, like let's pretend this did not say 12 equals 12. Let's say it said 12 equals 13. Then you would say no, as in no solution. What would that mean graphically? It means that they don't cross, right? So right here, 12 does equal 12, always. That means infinitely many solutions. Something impossible would be no solution. Yeah, I'm done. Keep working. Answers are on the back.